In titration analysis, the color change of indicator is usually used to indicate the endpoint. In this lesson, we will learn the principle of endpoint indication and indicator selection of complex matrix titration. First of all, let's talk about the principle of endpoint indication of complex matrix titration. Metallochromic indicator is an organic weak acid or weak base, as well as a complexing agent. Before the end of titration, excess metal ions M complex with indicator Rn to form complex MIN, and the solution exhibits the color of complex MIN. As the titration goes on, M gradually complexes with Y to form the main reaction product My. When the titration approaches the stoichiometric point, EDTA exchanges with Rn in complex MIN to release the indicator. The solution shows the color of indicator Rn. The change of the solution color indicates the titration reaches the endpoint. The metallochromic indicators applied for endpoint indication should meet the following criteria. It can change color in the jump range of PM, and the color change point PMT should be as close to PMSP as possible. The color change of endpoint should be obvious and is convenient for eye observation. KMIN less than KMY, and the KMIN value is usually 2 orders of magnitude smaller. If KMIN is too small, the exchange speed will be too fast, leading to an advanced endpoint. If KMIN is more than KMY, the exchange reaction is difficult to be carried out, causing a delay or even no endpoint. The reactions involving color change should be sensitive, rapid, and selective. MIN is soluble in water and stable for storage and use. Next, let's learn about the calculation of color transition point of metal indicator PMT as a PM value at titration endpoint PMEP. Color transition point of indicator PMT, the negative logarithm of metal ion concentration when MIN equal to Rn prime. The solution color changes appears to be intermediate color. The color transition point is used as an endpoint of titration PMT equal to PMEP. Taking the side effects into account, there are 2 solutions. When the indicator has an acid effect, the expression of PMT and PMEP can be obtained as follows. PMEP equal to PMT equal to log K prime MIN equal to log K MIN minus log alpha RNH. When the side effects of metal ions M and the acid effect of indicator N exist at the same time, the titration endpoint PMEP prime is obtained according to the formation relationship. Several problems should be fully considered when using indicators. Indicator blocking. When titrating metal ion M, if there are other metal ions N in the solution, and KNIN more than KNY, the solution will always present the color of complex NIN formed by N and Rn. Even if the reaction approaches a stoichiometric point, this phenomenon is called the indicator blocking. For example, taking iochrome black tea as an indicator, in the titration of the total amount of calcium ion and magnesium ion with EDTA at pH 10, coexisting aluminum ion, ferric ion, copper ion, cobalt ion, and nickel ion will block EBT, so the end point will be impossible to see. It is necessary to separate or add masking agents to eliminate interference. The masking method is as follows. Trace anomine can mask aluminum ion and ferric ion and tartaric acid can mask ferric ion, while the addition of potassium cyanide or sodium sulfate can mask copper ion, nickel ion, cobalt ion. After adding mask agent, these interfering ions won't form stable complexes with EBT, thus eliminating the interference to the end point of titration. Indicator ossification. When the solubility of the complex mRN or indicator Rn is too small, the reaction of EDTA displacing Rn in mRN becomes slowly as the endpoint is delayed. Solvent solution. Add organic solvents or increase the solubility by heading to accelerate the reaction, thus make the color change at the endpoint obvious. Indicator oxidation. Metallochromic indicators are mostly colored compounds containing double bonds, which are easily deposed by sunlight, oxygen, and air. In aqueous solutions, it is usually layable and easily be deteriorated. For example, EBT decomposes quickly at the presence of Mn4 and Ce4. Solvent solution needs to prepare the indicator in a solid state. Mix with a reducing substance, such as a sorbic acid or hydroxylamine, or use it immediately after preparation. Here is a commonly used metallochromic indicator ABT. ABT is a weak acid azo dye, which can form red complexes with many metal ions. The complex exhibits different color with a change of solution pH, and pH 9 to 10.5 is most suitable range. ABT can be used to indicate the endpoint of titration of zinc ion, cadmium ion, magnesium ion, and mercury ion with EDTA. The solution color changes from red to purple and finally becomes blue to the end as titration proceeds. Today, we have learned the principle of endpoint indication and the selection of indicator. The obvious color change of the indicator near the endpoint shows the titration end.